Hi girls, this would be lesson 2 on Geometry 2 and we focused on alternate angles, right? So let's just recap. Vertically opposite angles is where we have the shape of two lines intersecting and they form the shape of an X. And we have the angles that are opposite or vertically opposite each other being equal in measure. So that was theorem 1, vertically opposite angles are equal in measure. Theorem 2 then is based on alternate angles, right? Now, I haven't come across or haven't come upon what Theorem 2 says yet, but I want to introduce you to a new term, which is the transversal. So what is a transversal? So this is one of the key words that you could put down. A transversal is a line that cuts two or more lines, and it's called a transversal, right? So transversal is where it cuts two or more lines. So basically you draw two lines and you have a line going down through them. So that red line is an example of a transversal. This red line here is an example of a transversal. So it cuts two or more lines. Alternate angles, what are they? So alternate angles, think of the word alternative. This is what I always say to my students when I'm going through these. Think of the word alternative. So alternate angles are on opposite sides of the transversal that cuts two lines but are between two lines. Okay, now at the moment you're like, what does that mean? So they're on opposite sides of a transversal, which remember is a line that cuts down two lines, but they're in between the lines. So for example here, we have two parallel lines, right? So they have to go between parallel lines, okay? That's another point that should be made there, between two parallel lines. So we have two parallel lines here. We have a transversal cutting down here. So we have that angle there. What do you think is going to be the angle that's equal to that shaded one? This angle here. So think about it. They're on opposite sides. So opposite sides within the two parallel lines, opposite sides of the transversal. So as it says here, they're alternative to each other. So think alternative to each other. Alternate angles are on opposite sides of the transversal that cut two lines but are between two lines. So that cut two lines but are between two lines. So think of their alternative on different. Alternative means different. So alternate angles, here's another way that we could have alternative angles. Okay. Remember to look for the Z shape, right? So look, there's a Z shape here. Within the Z shape is the alternate angles. So as they'll mark here, look at the Z shape. So angle A is equal to angle B. So remember, alternative angles, they're on opposite sides of the transversals and they're within the lines, right, or the parallel lines. And look for the Z shape. Look here. These are also alternate because they're on opposite sides of the transversal and they're within the parallel lines. Okay. So what does Theorem 3 stand for? Theorem 3, and you need to take this down, if a transversal makes equal alternate angles on two lines, then the lines are parallel. So if a transversal, which is a line that crosses two lines, if it makes equal alternate angles, then the lines must be parallel. Obviously, what we can say as well is that if the alternate angles are equal, the transversal has cut two parallel lines. So take down the diagram. We have line L, line M, we have a transversal cutting them. We have angle A and angle B. They're actually equal in measure because the transversal is cutting two parallel lines. So that makes them equal. So if angle A is equal to angle B, then we can say that line L, remember the two straight lines together mean parallel, is parallel to M. And they are parallel, going in the same direction. They'll never meet, they're equidistant from each other. The converse, which is like the reverse of this statement, and it's just another way of saying it, is that if we have two parallel lines, then the alternate angles formed by a transversal are equal. Okay, so if we have two parallel lines, L and M, look at the arrows denoting that they're parallel. Angle 1 is equal to angle 2. So we can also say that if L is parallel to M, then angle 1 will be equal to angle 2. Okay, another type of angle that I'm going to introduce you to is corresponding angles. So think of the word correspond. It usually means kind of like to say the same, or, you know, I don't know, I suppose like to do something the same, correspond. So corresponding angles are on the same side of the transversal that cuts two lines. So one angle is in between the lines and the other angle are outside the lines. Right, so what do we mean by that? So again, take down the definition of what a corresponding angle is. So we have two lines, we have a transversal. Corresponding angles are on the same side of the transversal and they're either both beneath the line like that or like this. They're both on the same side of the transversal but both above the parallel lines, so they look the same as well. Here again, corresponding angles, they're both on the same side of the transversal, the right side here, both above the parallel lines. And then finally, another way of showing corresponding angles is they're both on the right side of the transversal and both underneath the parallel lines. Okay, so maybe draw two of those diagrams then to represent corresponding angles. So remember to look for the F shape. So what do you mean by the F shape? Look at this. So angle A is equal to angle B because they're corresponding angles. They're both on the same side of the transversal and they're both on above the parallel lines. But look at the letter F. Right, see the letter F there? Can we see the letter F here? See there again, so we're looking for the letter F. With alternate angles, we're looking for the letter Z. So theorem 5, take this down. Two lines are parallel if and only if for any transversal, the corresponding angles are equal. Okay? If the corresponding angles are equal, the transversal has cut two parallel lines. Okay, so just be careful with that then as well, right? So two lines are parallel if and only if for any transversal, which is the line that cuts the two parallel lines, the corresponding angles are equal. So we have line L, we have line M, transversal going down here, angle A being equal to angle B because they're both corresponding angles. The converse then, right, so if angle A is equal to angle B, then we can say that line L is parallel to line M. The converse then, which is another way of saying this statement, is that if we have two parallel lines, then the corresponding angles formed by a transversal are equal. Okay, so two parallel lines, they're both corresponding angles because they're on the same side of the transversal and they're both above the parallel lines. So if L is parallel to M, then we can say that angle 1 is equal to angle 2. Okay, so let's look at this diagram here. I'll zoom in there. And without measuring, how would we work out angle 1, angle 2, angle 3 and angle 4 measurements? Okay, is there anything that we can spot straight away? Right, so let's look at this angle here, right? So I'm just going to focus with, we'll start with 1 then, right? So let's work out angle 1, right? So what do we know about this whole angle here? That this whole angle here is a straight angle, isn't it? So, and they're supplementary angles. So if you know this is 120, how do you work this? Take it away, take 120 away from 180. And that would give me 60 degrees, okay? So we'll mark that in 60 degrees there. Now let's look at angle 2. Can I work at angle 2 yet? No, maybe not. Could I work at angle 3? Yes, I could. Look at this. This is a transversal. It's cutting two parallel lines. This is corresponding to this. So angle 3 is actually corresponding to this angle here. So they're equal to each other. So, oh, actually I could have worked out angle 2 there. So angle 3 is going to be 120 degrees. And actually, sorry, I could have worked out angle 2 there. Apologies. I could work out angle 2 by doing alternate angles. So aren't they both within the parallel lines and they're on alternate sides? Or you now know this is 120, so angle 2 could be equal to that through vertically opposite as well. Okay, so we have 120, 120. We have 60. Could I work at angle 4? Yes, I could. Angle 4 would be the same as angle 1 as they're vertically opposite. So angle 2, 120 degrees, equal alternate angles. Angle 3, 120 degrees, equal corresponding angles or vertically opposite as we said. And angle 4 then 60 degrees, a straight angle or vertically opposite to angle 4. Okay, so that is your lesson on corresponding and alternate angles, and I'm going to give you a few questions on that.